Okay, so for the first function, we got this 2 root x, and we're looking at it from 1 to 3. So the first part you got right, you want to revolve around 1a, says revolve around the x-axis. So you knew to do disk method. All right, and what you realized, you used the right formula, but you realized if you're going around a horizontal line and you're doing the disk method, you do a function of x. All right, that's going to be your radius as a function of x. If it's a vertical line, then you change everything to y. This is with the disk or washer method. Okay, so that's one thing to remember. Like, it always helps me when I do these to say, okay, if I'm doing disk washer and I'm going x-axis or horizontal line, function of x, which is what you did. So you said I'm going to go for 1a, you said I'm going to go from 1 to 3 x values, and I just need pi r squared, the 2 dimensions, and then 3 dimensions when you integrate. So pi r squared, so the radius is the distance from here to here, right? Because when you rotate it around, it's that distance, which is just represented by the function. Okay, very good. Now for 1b, you did realize that it was when I rotate around a vertical line, when I go around x equals 2, you realize it was function of y, so you got that part right. However, what you need, here's the problem with this one. What you need when you do the disk method is a represent, just like when we did it this way, it was a distance from here to here, right? That was the radius when you rotate it around, which would be the same everywhere in the function. It depends on that function of x up here, y equals 2 root x. Here's the problem with what you're trying to do when you try and do the disk method. For this case, you need a representation. So you're going to rotate around this way. So you need a representation of the distance from here to here, right? However, there's a problem here. You can do it this way, but it's complicated. You'd have to break it into 2 separate intervals from here to here, right? Because it'd always be 2. The distance from here to here is always 2. But here it would change, right? It's going to depend on this relationship, and you'd have to solve it for x, right? Because we decided it's a function of y. So you'd square both sides. Y squared equals 4x. Divide by 4. And x equals, same equation, x equals y squared over 4. Okay, so but that's just this one. And then we have to figure out the y balance. So it's really complicated to do the disk washer. So that's why I was trying to get you to do the shell method for that one. So let me show you how much easier it is for the shell method. For the shell, it's different, right? So here's your rules for the disk washer. For the shell, it's good to remember that when you have a horizontal line to rotate around, it's backwards. It's different, right? A horizontal, and in this case, we're doing vertical, so let's start with this one. Vertical, we use function of x. Horizontal, we use function of y. Okay, so when I do that for b, what I need to do is, I always like to draw this for shell method. I do this, and you revolve around here, and you have like a parallel rectangle with your line of revolution. So if you remember, for the shell method, it goes like this. It's going to be 2 pi, and then your bounds from y goes from here up to here. Okay, so that's going to be the y value, right? Because we got to write a function of x value, function of x. Look at my notes here. Vertical, function of x. So x going from 1 to 3, so that's easy. All right, and now we have 2 functions. All right, we got 2 functions here, and the first is the distance let me use pink, from here to here, right? That's going to be 3 minus x, right? So if this were 2, 3 minus 2 is 1. That's the distance here. If we're further back, it's always going to be 3 minus x. So that's what I think the book calls p of x. It doesn't matter. It's just your distance from this rectangle I draw to the line. And then this is the height of this thing. Okay, so the height of this thing is just given by the function 2 root x. Okay, so that's much easier if you do the shell method. right? And then both of my answers could be functions of x. I don't even have to mess with writing that as a function of y. Okay, so that's always what I start with. So there's kind of two things going on here. The kind of the outline of this, right? It is, do I write functions of x's or functions of y's when I do it? And that depends on which method and if it's vertical or horizontal, all right? And then the next thing is I'm doing the shell method. I need two functions. One that's the distance from the line to the rectangle that I draw, and one that's the height of the rectangle. If I'm doing the washer method, I do the radius thing, right? Pi r squared. In this case, there's no washer to deal with. It's just disk because there's no hole, and you got that one right. You nailed that one, so that's good. Okay, let's look at the next one because you had some issues with the next one. We're doing. So let's see if we can apply that. What I'm talking about. Let's see if we can apply that for the second one. So I got root x and x squared in quadrant 1, and we're going to rotate around the y. Okay. So let's see if we can apply these rules. So I got root x, picture always helps. So I got root x, which looks like that, sort of, and x squared, which looks like that. So this is my region, right? I want to rotate around y. So we can know that this guy's this y equals square root of x. So if we need to, which we might, square both sides. Y squared equals x. So x equals y squared. This one is y equals x squared, square root both sides, root y equals x. And we only have to worry about the positive since we're in quadrant 1. Okay, so let's see. I'm going to do, if I want to rotate around the y-axis, I got to use the shell and the disk method. Let's start with the disk method. Okay, so the disk method says I need, this would be the point 0, 0, which will be important, and this will be the point 1, 1. All right, that's when these guys are equal. Okay, so if I use the disk method, I'm going vertical axis of revolution, which means I need functions of y, right? Disk, I'll call it disk slash washer. All right, so if I say vertical, the first thing I need to do, and you missed this when you had functions of x, is if it's a vertical line disk washer, we need to do functions of y, okay? And then the next part is the big radius and the small radius. So this distance is the bigger radius, right? As you go left to right, that's what I'm going to call big R of y. And then the smaller radius would be from here to here, right? That's little r of y. So I have to subtract this one, and I have to take this one, the bigger one, square it, because your formula goes like this. It'll be pi from a to b, which would be, well, in either case, 0 to 1, but these should be the y values. So what I'm looking at is the y values here, right? Function of y. So I go from 0 to 1, and then I do big R squared minus little r squared dy. All right, both functions of y. So that means I should have some y's in here. So using those formulas really helped me kind of figure out what I'm doing. So big R is distance from here to here. That's the y equals x squared curve, which I already took care of that. Y equals x squared would be x equals root y. So that's root y squared. And then I subtract from that little r, which is my square root function, but square root function, function of x. So it should be that function. So I'm going minus y squared squared. All right, and that's it. That's the big radius minus the little radius squared times pi washer method. Now, if I go shell method, we remember that if I got a vertical line, then we go functions of x. It's the opposite. So what I always do is I draw this little rectangle, right? And then I ask myself, okay, if I'm going to rotate around this axis, all I need is a representation of this distance from this rectangle to the line of revolution, and that should just be x in this case. And then I need a representation of this distance, which is one function minus the other functions of x. So the shell method would give me, we go 2 pi, and then it's over x's, so I go x to x, 0 to 1, coincidentally the same thing. My function that is distance from axis to rectangle, x, and then my function that's the distance. So in this case, the distance would be the bigger one subtracting the little one in my functions of x, the original functions given. So it's x, which one's on top? This guy's on top, root x minus, and this one's actually on bottom, right, over this interval, the x squared term. Not squared, just one times the other, right, because we're doing the shell method. Okay, so again, quick review. If I'm doing washer, I got to go, and it's vertical, it's got to be function of y. Find the outer radius, subtract the little radius, square both of them. Multiply by pi, bounds of y. If I'm doing the shell method and it's vertical, function x, right, in this I need a function that represents distance from rectangle to axis, and then I got to multiply that by the height of this rectangle, right, because that's the guy that's going to get rotated around. It's going to make a bunch of shells. Okay, so I hope that clears things up. You had some other mistakes in here. Let's see. What else can we take a look at? That one looks good. That's you did that by parts, I believe. It'd be nice to see a little more work, like what's U, what's dV, which probably be useful in doing the work here. This one looks good. This one looks good, kind of pattern recognition. This would be a use substitution, which you did correctly. Oh, this problem, let's see. Yeah, I'm not sure. It looks like you might have just been a little lost on this one. So for 7, you're supposed to set up, the directions say to set up the integral that represents the arc length. Okay, so really you're just, and this goes for this one as well. You're just really relying on those formulas. If you look at your formula for arc length, you should have something like, oh, that's my integral sign. Let me do it on here. It's kind of harder to write on this guy. So for arc length, you should go over your, something like this, from A to B, and then it's the square root of 1 plus your derivative squared. Right, so I don't see that anywhere. I see your root and your derivative. So you kind of have, I mean, you have that there, but it's just you really got to follow your formula, right? If you have your formula for arc length, it should look like this. So you should be kind of evaluating that guy. And then I asked you for the other one to do it as a function of y, right? So reevaluate those formulas, because you gave me 2 functions of x, it looks like, both times. Okay, so really you're following the formula. So you would have to solve this for x like we did in the previous problem. And then you have a function of y once you do that, and then that's going to go for your derivative when you do the other one. Okay, but you need integrals, you need bounds. So review that formula. And the same thing goes, it looks like you did that for the surface area, right? You got that, most of it. That looks pretty good. There's your arc length, right? There's your arc length formula. However, that's not right. You got an x in there, but if you look at your formula, that should be the function value. That should be this guy. Okay, so take another look at your formulas for surface. This was just a matter of kind of fitting your problem to the given formula. A little bit easier than disk and washer, because those you got to really decide what to use. But for these ones, you should just be saying, okay, here's my formula. Here's what I'm going to do. Plug in the function value, plug in square root 1 plus the derivative squared. Let's see. This one, you're going to do separation of variables. So you got to separate these guys. There's some similar examples in your book. When I say separate, I mean if you got dr ds equals e to the r minus 2s, you should be able to separate those. For example, multiply both sides by d. Well, here's the key. E to the 2s. That's the same thing. That is, remember, your exponent rules say r minus 2s. If I write this as a fraction, e to the r divided by e to the 2s is the same as e to the r minus 2s. And that'll allow you to separate when you have that fraction equal to that fraction. Okay, I got a limit on my video here. Let me know what other questions you have, and also send some more resources that you're asking for. I got a couple good ones.